Hi students, myself Jamuna, working as an associate professor at Nanda Engineering College located in Erode. Now I am going to deliver lecture on wind energy. So first we will see wind formation, how the wind is formed. Wind resources originate from the sun's uneven heating of the earth. So the sun uneven heating of the earth is the main cause to create wind in the earth. So which creates the uneven heating, which creates temperature and pressure difference that drive air movement. So this movement of air is known as wind. The sun energy heats the earth's surface unevenly. Areas near the equator receives more direct sunlight and thus heat up more than areas near the poles. And warm air expands and rises and creating the low pressure. So usually warm air which rise and creating low pressure area. At the same time the cool air is denser and sinks creating areas high pressure area. So air always flow from areas of high pressure to low pressure which produce a wind. So this is the wind formation diagram. As I said, cool air from high pressure area which moves to the low pressure area, and warm air from the low pressure area which moves to the high pressure area which creates the wind. This is the wind direction. These all are due to sun's uneven heating of sun. So again this diagram also represents the wind formation. In this we know hot air which rises up and the cold air will come to the low pressure area, and that movement will cause the wind. Wind resources. Wind resource refers to the kinetic energy of moving air that can be converted into the electricity using wind turbines. It is the renewable and sustainable energy. So in that we will see what are the resource assessment. The resource assessment involves evaluating the ability and characteristics of wind at specific location, and this including the measuring wind speed, wind direction and frequency over time, often using specialized equipment like anemometer. We know anemometer which is used to measure the wind speed, and wind resource maps also. And wind maps and database means various tools and resources such as wind resource maps and database like DOE's wind resource database help in identifying potential wind energy sites. This wind maps and database used to identify the potential area of wind. And factors affecting wind resources are wind speed and direction can be influenced by the factors like terrain, vegetation and proximity to the large bodies of water. These factors will affect the wind resources. And this is the wind power density in India. In this brown color which represents high wind power density 350 to 450, and slight brown which represents the low wind density when compared to brown one, that is 3 to 350, and yellow is 250 to 300. Last one is red. Red has the wind power density of 2 to 250. This is the wind power density status in India. And nature and occurrence of wind, that is how wind is producing. As we all know pressure difference, so wind the air usually moves from high pressure area to low pressure area. That is due to uneven heating of earth, the sun's uneven heating of earth. And third one is Coriolis effect. This is nothing but the earth's rotation deflects moving air. As we know, earth is rotating on its above axis and it's also rotating around the sun. So the earth's rotation deflects moving air, causing winds to curve, so which causes the winds in curvely nature. In the northern hemisphere this deflection is in right, and in southern hemisphere it is in the left. So the Coriolis effect is that produce the curved nature of wind. And local topography is another reason for occurrence of wind. The mountains, valleys and coastlines can influence the wind patterns, creating local wind systems like sea breezes and land breezes. And wind power installation. India's first wind turbines were installed in 1986 at demonstration wind farms in coastal area of Maharashtra, Ratnagiri, Gujarat and Tamil Nadu. These projects utilized 55 kilowatt Vestas wind turbines and were supported by the Ministry of New and Renewable Energy (MNRE). So the first wind farm is installed in India is Maharashtra. And wind power installation. Wind power generation capacity in India has significantly increased as 31st March 2025. The total installed wind power capacity will be 50 gigawatts. India has the fourth largest installed wind power capacity in the world. And this is the pictorial representation of wind power generation in worldwide. The first one is China and second one is USA and third one is German. We are in fourth place. In wind power generation capacity in worldwide, we are in fourth place. And this is the wind energy producing sites in India in state wise. So Gujarat is the first one and Tamil Nadu is second one, Karnataka third, Maharashtra and then Rajasthan, like that. Now we will, that's all the general information. Now we will enter into a technical terms or technical information. Components of wind energy conversion system. So this is the, as some of them we have seen this diagram. So this is the construction of wind turbine. As you see this diagram, you know the parts of wind turbine. This is the rotor, that is a wind blade, gearbox, nacelle, generator, power cables, tower, switchyard, transformer, like that. This is the inner component of nacelle and yaw motor, yaw drive, like that. These are all the main components. This is the pitch, rotor, and then this wind turbine is connected to it has low shaft, so which is connected to gearbox, which speed up this speed and gives to the, that is connected to the generator shaft. And then we have controller in this. These are all the components which is located in the nacelle. The controller and anemometer, which is used to measure the wind speed and high speed shaft. And below that we have yaw drive, yaw motor and tower, like this. These are all the this rectangular box. Inside this rectangular box we have many components, that is called nacelle. So the anemometer, we know anemometer is used to measure the wind speed, and wind vane is used for wind direction and speed measurement. Also it is communicated to the controller. And when the wind turbine rotates, mean when the speed is about 10 to 26 km per hour means it start rotate. When it stops means when the speed reaches 88 km per hour means by using a brake system we will stop the wind turbine, because when the wind turbine rotates above the speed means it will damage. And gearbox works which is same principle as in car, which gear up the speed and is given to the generator. And pitch turns the blade out of the wind when there is and in this way the controls the speed of the pitch turns the blade. And yaw drive, that the turbine continues, which ensures that the turbine continues run on the wind direction, which is controlled by yaw motor. And so the working principle of the wind energy conversion system is the kinetic energy of air, which is converted into electrical energy. So if we see the diagram, when wind hits on the rotor blade means the wind turbine will rotate. That speed is geared up by using gearbox, which is given to the generator. As we all know, the generator is which converts the mechanical energy into electrical energy. So that converts the mechanical energy into electrical energy, which is given to the the transformer steps up the voltage which was given to the grid. So this is the working principle of wind turbine. So, and we have seen some of the components, that is controller, which is used to control the yaw motor and wind van like that, and then pitch like that, and the anemometer, which is used to measure the wind speed, and we have brake system, that is the electrical or mechanical brake system. When the wind speed, if there is any unwanted situation, or when wind speed goes above the 90 km/h means that brake system will come and act and stop the wind turbine. This is the working principle of the wind turbine. So the winds, that is wind energy system. The wind energy system which converts the kinetic energy into electrical energy. And the power equation for wind system will be a P equal to half rho pi r square V cube. V is wind velocity, r is the radius of that swept area radius, and the rho is air density. So rho P equal to power equal to half rho air density into pi into r is the radius, and V is the wind speed. And working of wind turbine is aerodynamic force. So the lift and drag force which rotates the wind turbine, that is wind blade. The lift force is higher when compared to the drag force. And this is the block diagram of wind system. So when wind hits on the turbine means the turbine will rotate, that is the wind blade will rotate, that is gearing by gearbox and coupling to the electrical generator. That generator will produce the electrical power which is given to the load. So we have controller here. This controller may be your IoT or embedded or microcontroller like that. So the input to the controller will be a speed, and then generated temperature and output power, and then the wind direction. The output from the controller will be pitch control, and then control signal to the generator. Why? If you see this diagram means mostly we are using 3 blades in the wind turbine. Why means if we use 2 blades means that is too expensive with added risk. If we are using 2 blade means, so 3 blades means optimum, and if you use 4 blade means not very cost effective. It is not if you use 4 blade means that is not a cost effective one. And wind power curve, this is the wind power curve which is drawn between the power output and wind speed. If you see this curve means when the wind speed is 13 km/h means that is called cut-in speed. So the wind turbine rotates and which produce electrical energy. When the wind speed is 50 km/h means we will get rated speed, that and that speed we will get maximum power. After that also it gives the power and it slightly decrease at 100 km/h. That is the cutout speed. If you run the wind turbine above that speed means the wind turbine will damage due to high speed. So when the wind speed reaches the 100 km/h means we have to stop the wind turbine by using a braking system. This is the wind characteristics. The first one is macro meteorological range and spectral gap, and then micro meteorological range, so which is drawn between wind speed or frequency to the time period. And this wind spectrum is from Western Europe. In this diurnal pattern, day, that is due to day-night effect, we had a diurnal pattern. One day wind pattern is diurnal, and 4 days is this. 1 year is that is called annual pattern, and 1 hour is spectral gap, and 1 minute which is in micro meteorological. These are all in macro. Macro means which has diurnal, annual, and 4-day pattern. 1 hour is spectral pattern, and micro meteorological range which has the 1 minute pattern. So the micro meteorological range which is affected by turbulence. That is, turbulence means irregular changes in wind speed and direction which can be influenced by terrain and obstruction like buildings or tree. Why is turbulence bad for wind turbine means reduced production of energy. If there is a high irregular speed means turbulence means irregular speed that reduce the power production and increase wear and tear and shorten lifetime of the turbine and increase dynamic loads on the blades. So this is the turbulence is, this is the reason why turbulence is bad for wind turbines. And types of wind turbine, until now we have seen horizontal axis wind turbine, that is the first diagram, and second one is vertical axis wind turbine. In horizontal axis wind turbine, all the components which is located at certain height, but in the vertical axis wind turbine, the components are located in ground. And this is the difference between the horizontal axis wind turbine and vertical axis wind turbine. So we know major components are height at horizontal axis wind turbine. In vertical axis, major components are at ground level. Horizontal axis speed is high, its speed is low. Vertical axis maintenance, in horizontal axis maintenance is high because all the components are located in some height, and vertical axis it has low maintenance. In horizontal axis again it is located in height means it has cable standing problem, and in vertical axis no cable standing problem. Horizontal axis has less lifespan and vertical axis has long lifespan. The installation cost of horizontal axis is very high when compared to vertical axis, and it run on high wind speed. We know horizontal axis, if it is located at certain height, so it runs at high wind speed. Its speed is low, and high tip to wind speed ratio, so high power output. It has low power output vertical axis, and starting torque is less in horizontal axis and high in vertical axis wind turbine. And rotation is parallel to the wind direction in horizontal axis, but it is perpendicular to wind direction in vertical axis wind turbine. These are all the main difference between the horizontal axis and vertical axis wind turbine. This is the sample picture for horizontal axis wind turbine on vertical axis wind turbine. Finally, we will see what are the advantage and disadvantage of wind energy conversion system. So first we will see the advantages of wind energy conversion system. As we know, wind energy is clean and one of the renewable energy, and wind turbine has slightly small physical footprint, that is carbon footprint is less, that it produce no carbon dioxide, it won't release carbon dioxide. Wind turbines can be installed on existing farmland, providing additional income to farmers, and wind energy help to reduce greenhouse gas emissions, that is CO2 emission. Wind energy can reduce the dependence on fossil fuels, reducing the risk of price. And wind energy is the domestic resource, reducing dependence on foreign oil and enhancing energy security. Wind energy can create jobs and stimulate economic growth in local communities. Wind energy can produce on small scale, making it accessible to individual homeowners and business. And wind energy can be combined with other renewable energy such as solar or hydro, that is called hybrid system. And then wind energy does not produce any emissions such as sulfur dioxide, nitrogen oxide that contribute to air pollution and produce health problem to human. And disadvantage of wind energy system is wind turbines can be noisy and disruptive to local wildlife including birds and bats. Wind energy is variable and unpredictable, making it less reliable than other source of power. We know wind turbines can be expensive, installed and maintained, making it difficult to compete with other source of power. As we know, the installation cost of wind turbine is high, but the government provides subsidies for this installation. Wind turbines can be visually unappealing and may impact the scenic beauty of an area. Wind turbines require consistent wind speed at least 6 to 9 meter per hour to be effective, limiting their potential use in certain areas. Wind turbines can pose a risk to aviation and interfere with radar and communication system. So it interfere radar and communication system. Wind turbines have a limited lifespan and require frequent replacement and wind turbines require a significant amount of land and may compete with other land use such as agriculture or recreation. Wind energy may not be cost effective in areas with low wind speed or high installation cost. Wind turbines require a substantial amount of energy to manufacture, transport and install, which may offset some of the environment benefits. These are all the disadvantages of wind energy conversion system. Thank you.